Good evening and gentlemen. I welcome you all in today's live class of chemistry. Children, we have completed the explanation of the exercise of all chemistry chapters. Is it? And now today I am going to start the revision work. And today I will discuss, I will revise the chapter acids, bases and salts. Alright children? So, children remember that in this chapter we have discussed mainly these three chemical substances, that is acid, second one is bases and third one is salts. So these substances can be categorized on the basis of their certain characteristics or certain properties. So before explanation, just take some substances and taste them like lemon juice, unripe mangoes, baking soda, table salt, curd, sugar and orange juice. So children, when you will taste these substances, so you will find that the lemon juice tastes sour, unripe mangoes also taste sour, baking soda it tastes bitter, table salt tastes salty, curd it also tastes sour, sugar tastes sweet and orange juice tastes sour. Is it? So, on the basis of these different tastes which are present in different substances, you can say that the sourness or the sour taste which are present in some food items like lemon juice, orange juice, unripe mangoes, curd, because of the presence of a acid. Get it? They contains acid. And because of presence of these acids, their tastes are sour. So most of the fruits are sour in taste because they contains a kind of acid in it. Alright? And such acids which are present in these food items are known as organic acids. What they are known as, children? Yes, they are known as organic acids. So, lemon juice, orange juice, curd, unripe mangoes, they all have the acid in it, and this acid is the organic acid. And most of the organic acids are weak acids. So that is why it does not put any harmful effect on our health. Alright. And another kind of acid is the mineral acid. So the mineral acids are those acids which are obtained from minerals. Alright. And the example of these mineral acids are hydrochloric acid, sulfuric acid, and nitric acid. So these are some of the examples of mineral acids. Get it, children? And most of the mineral acids are strong acids. So they are harmful. They can cause the serious skin burns. Get it? So how many kind of acids are there on the basis of their effect? It is of two kinds. The first one is organic acid, which are mostly present in food items, and these are weak acids. Second, mineral acids which are found, which are obtained from earth crust, and these are the examples of mineral acids, and most of the mineral acids are strong acids. Alright children? Now, come to the next. As you already have seen in your chapter, the name of different food items are the naturally occurring acids which are present in certain food items, and the name of acid which are present in them is also given there. So I'm going to explain it also, and you just learn it that which food item contains which acid. Okay? Orange, lemons, these all fruits are also known as citrus fruits. Get it, children? And the citrus fruits have the acid citric acid. Get it? Milk and curd. These are the milk products, and they contains lactic acid. Okay? Vinegar. They also contains an acid, and the name of this acid is acetic acid. Another food like tamarind, grapes, unripe mangoes, they all contains tartaric acid. And in proteins, also an acid is present, and it is amino acid. Alright? The tea which we generally use to drink also have a acid, and the name of that acid is tannic acid. And the next is apple. It contains malic acid. And the carbonated drinks, that soft drinks that we generally use to drink, contains the carbonic acids. Get it? So these are some naturally occurring acids present in certain food items of fruits and have different types of acids. So these all are the example of naturally occurring acids. Alright? Now, children, come to the properties of bases. The bases are those substances whose taste is bitter. Okay? And they feel soapy. So, for example, if you will take baking soda and if you will taste it, so what is the taste of baking soda? It's bitter. And if you will prepare a solution of baking soda while mixing some water in it and touch it with your finger, so you will feel soapy. So these are the properties that soapy in touch and bitter in taste are the substances which are called bases. Alright, and there are different bases which we are using, like baking soda is one of the very common base, and certain bases are also there like all metal oxides, hydroxides, carbonates, bicarbonates. They all are the example of bases. Alright, children? Some bases are soluble in water, and because of having this property, these bases are called alkalis. So, water soluble bases are called alkalis, whereas those which are not soluble in water, they can be simply called as bases. Alright. So all the bases are not soluble in water. Some bases are soluble in water, which are known as alkalis. Alright, children? Now, some examples of the bases are sodium hydroxide, and the formula is NaOH. And it is also known as, it is commonly known as caustic soda. So the chemical name of NaOH is sodium hydroxide and the common name is caustic soda, and this is a kind of base. KOH, potassium hydroxide. So the chemical name of KOH is potassium hydroxide and the common name is caustic potass. Okay? CaOH twice. This is calcium hydroxide, which is a base, and its common name is slag lime. Alright. Ammonium hydroxide, NH4OH. Its chemical name is ammonium hydroxide. So these are some of the example of bases. Okay, and they are soluble in water also. So these are the alkalis, you can say that, bases which are soluble in water. Alright, children? Now the third part is salts. So when acid and base reacts, children, we have discussed about the acid and bases now. So when these two react together, so they neutralize each other's by their chemical properties, and a salt and water are formed. Get it? So you can say that salt formed when an acid and a base reacts together. So as a result of this reaction, of this chemical reaction, salt and water form. Get it? So salts form when acid react with a base, and along with the salt, water also form. And one of the example of it is when hydrochloric acid, the formula of hydrochloric acid is HCl, and it is a base. When this acid reacts with a base, sodium hydroxide, alright, sodium hydroxide, that formula is NaOH, and the common name of the sodium hydroxide is caustic soda. Alright, so when hydrochloric acid and sodium hydroxide reacts chemically each other, it forms a salt, that is sodium chloride. And the formula of sodium chloride is NaCl. And along with it also forms water. Alright, children? Get it? So this is an example of the salt which form when an acid, that is sulfur hydrochloric acid, and a base, that is sodium hydroxide, reacts together. So it forms a salt, sodium chloride and water. Alright, children? Now the salts can be acidic, basic or neutral in nature depending on their composition. So you can say that all chemical compounds can be divided into these three categories. First acid, second bases, and third is salt. Okay? Now, then come to the next, as if a substance is either acid or base, so how we can know about it? How we can test it? So there are certain methods are used, certain substances are used which can be, yes, indicate the given substance is an acid or a base. Alright, and such substances are known as indicators. So indicators are which type of substances? The substances which indicates the given substance is either acid or bases. Alright, so they are called acid-base indicators. And one of the very common example of this indicator is litmus. Okay, litmus is a kind of indicator. Litmus is obtained from a lichens. The lichens are, children, actually the symbiotic association of an algae and a fungi. Get it? So from this group of the organism, a solution is obtained and this solution is known as litmus. And this litmus act as a acid-base indicator. Alright? Now the solution, litmus, is purple in color in distilled water. Alright? And it turns red in an acidic solution and turns blue in a basic solution. Alright? So in laboratories, in chemistry laboratories, we have the two kind of litmus paper. Red litmus paper and blue litmus paper. And when you put a drop of given substance, so what will happen? The color will change, and if the red litmus paper turns blue, so this indicates that yes, it is a base. And if blue litmus paper turns red, so this indicates that it is an. Alright, so you can say that the acids can change the red litmus paper into blue, and the bases can change the red litmus paper to blue, and the acid can turn the, yes, blue litmus paper to red. Okay, all right. So the litmus is a kind of indicator, and as it is going to obtain from natural substance, that is lichens, so it is termed as a natural indicator. All right. Now, along with this litmus, we have some more natural indicators. So the second one is turmeric. It is also a kind of indicator. Children, you must have seen the turmeric powder which is used in kitchen. And if you will prepare the turmeric paper that can be prepared very easily, just take a bowl, put a spoonful of turmeric powder, add some water in it and make a paste. Alright? And apply that paste on a white page on both the side. Apply that paste. Now dry it. And when the yellow paper get dry, now cut them into strips. And now this is your turmeric indicator ready. And you can use this strips of turmeric to taste the nature of substances. Alright? So if this yellow color of turmeric indicator changes to red. So this indicates the substance is a base. And if yellow color of turmeric indicator remains the yellow, so this indicates the given substance is a acid, or it may be a neutral substance. Alright, because a turmeric indicator will not change its color in acid or in neutral solution. It can change to red only in basic solution. Okay, alright. So this is the second, this is another natural indicator. One more natural indicator is there. Remember that we have discussed in the chapter and we have done the activity also. Is it? And that indicator is China rose solution. China rose indicator. Children, you must have seen the China rose flower or hibiscus flower. It is also known as hibiscus flower. And their petals are red in color. So this petals of the China rose flower are used to prepare the China rose indicator. And the method is very simple. You can pluck the China rose petals, few China rose petals, and boil it in water for few minutes. So you will observe, you will see that the water is going to turns to pink. Okay, now cool that and filter it, and you will have the pink color solution, and that is China rose solution, and it will act as a indicator. Alright, and you can taste the acids and bases with this indicator. So, if this pink color going to turns dark pink, so this indicates that substance is acid. And if this pink color changes to green, this indicates the substance is a base. Get it? So, by using this China rose solution, we can also find out the given material is an acid if it turns dark pink, or a base if it turns green. And if there is no change in color, it means that solution is, or that substance is neutral substance. Get it, children? And just like that, in these all indicators, like this litmus paper, if that substance is base, so it can turns the red litmus to blue, but it cannot turns the blue litmus. So blue litmus remains blue in presence of a base or a neutral substance. Only it can turns to blue if a substance is a base. And just like that, the red litmus paper and the blue litmus paper also turns red only in the presence of acid. And if it is not acid, so the blue becomes blue. There is no change. And for neutral substances also, the change will in color will not occur. Get it? So these are some natural indicators which are used to, yes, find out the given substance is either an acid or a base. Now, along with these three indicators which are natural, we have some synthetic indicators also that present in labs. Already, they are made up from certain chemicals, so they are known as synthetic indicators. And the synthetic indicators are the first one, methyl orange. And the second one is phenolphthalein. Alright. So these are the two synthetic indicators which are also used to, yes, find out the given substance is either acid or bases, or to test acids and bases. Children, this methyl orange, it turns red in acidic solution and yellow in basic solution. Alright? It turns red in acidic solution and turns yellow in basic solution, whereas this phenolphthalein, which is colorless in acidic solution and pink in basic solution. Alright, so they can change their color in acidic and basic solution to indicate the given substance is either acid or bases. Alright, so these all are the indicators which are used to test acids and bases by changing their color. Okay, and I hope that you understood these all kind of indicators which we have discussed. We have discussed the three natural indicators, that is litmus, turmeric and china rose solution, and two synthetic indicators, that is methyl orange and phenolphthalein. Alright, now come to the next topic of the chapter. Types of acids. Children, acids are different types as we have discussed that the first one is mineral and organic acid. Alright, mineral and organic acids. So, mineral acids are the acids which we obtain from, yes, certain minerals, and the organic acids are the naturally occurring acids which are present in certain food items. Okay, now the second type of acid is concentrated acid and dilute acid. Concentrated and dilute acids. Children, the concentrated acid, it means the, yes, the quantity of water in which the acids dissolve is less. So if the quantity of water is less, then it will termed as concentrated acids. And the dilute acid, if the quantity of water is more in which acids are dissolved. So such an acid is known as dilute acids. Get it? Like the hydrochloric acid, it consists of hydrogen chloride gas which is dissolved in water. So if this hydrogen chloride gas dissolved in a small quantity of water, it is known as concentrated hydrochloric acid. And if the same hydrogen chloride gas is dissolved in more amount of water, so the strength of the resulting acid reduces and this acid is then said to be dilute acid. Alright, so we can say that the concentrated and dilute acids, they are depending on the amount of water present in it. Okay? Now, there are certain physical properties of acids are also there. The first physical property, that acids have a sour taste. Second physical property, children, remember that we have discussed the acids can turn blue litmus red. So this is also a physical property of acids. Turns blue litmus red. And the next property is it conducts electricity. Alright, so all acidic solutions, they can conduct the electricity. Electric current can pass through it. And the fourth property is they are corrosive in nature. Right. So acids are corrosive in nature. Means that strong acids can destroy paper, cloth, or wood. And the acids also corrode metals such as iron and aluminium. And therefore, the acids are not stored in metal containers. They are stored in glass containers. Alright. And the mineral acids can cause the burn on the skin and therefore should be handled very carefully. Okay, children? One more property is there, that acids are soluble in water. Alright. So when an acid is dissolved in water, a dilute solution of the acid is formed and the heat is also given out. Get it? So which kind of solution form? Yes, dilute solution and heat is produced. And for this reason, it is dangerous to add water to acid. Okay, so to dilute an acid, always add acid to water slowly with constant stirring. Okay, don't add water to acid. Always add acid to water. Alright, children? So these all are the, yes, physical properties of acids. Now, acids have certain chemical properties also. Like they can react with metals, they can react with carbonates, okay? They can also react with bases. Get it, children? And the uses of acids are there. Mainly they are used in different industries, chemical manufacturing industries, and also used to purify the salts. Alright. So these are the topics of the chapter acid, bases and salts which we have revised today. And I hope that you understood these all topics. Alright. Thank you and have a nice day.